So welcome to the second day of KVM Forum. I'm going to open very quickly with the QEMU status report for this year, and then we can split again the two rooms. I will start with some highlights about various parts of QEMU and various kind of changes that happened this year. For accelerators, we removed hex, nomen omen, as you say sometimes. Like hex was a hypervisor that Intel developed for the Android emulator. It went unmaintained since Windows got support for WHPX a few years ago, and we just removed it from QEMU as well. TCG plugin support was brought onto Windows. The only problem was just basically build system stuff, so there was nothing that was really blocking the plugins from working. For KVM, we have some nice changes. Xenon KVM support is way more complete and basically usable. SAV SMP support is the first big full-blown implementation of constitutional computing for x86. It was some nice work done in collaboration between Intel folks for TDX and AMD folks for SMP. And also we have a new architecture, which is Long Arch. It's been supporting TCG for a while, both as a host and a guest. And now we have also KVM support. For the build system, Jon Snow and I had this pet project of having a Python virtual environment so that everything that uses Python during the build use just one Python interpreter. This makes it easier to use newer Pythons on CentOS 8 and /15. CentOS 8 is actually not anymore a supported build OS, but it actually works. Like, it's just that we don't support it. And also we upgraded to Python 3.8. Also in the build system, we have automatic dependency download. Right now we have two kinds from pip, from the Python package index, and also for Meson subprojects where libraries like libftt and libslurp now are not anymore submodules, they switch to Meson subprojects. And also, spoiler alert, this might be extended in the future to Rust crates. And finally, we have an interesting change to run functional tests without Avocado. It's a new thing, so I'm not super up to speed with it. I'm not sure whether you can still run them with Avocado, but anyway, this makes it easier for developers to run the functional tests for some kinds of changes, for example, Xenon KVM changes. We had a lot of changes from our retro computing fans. 68K can run a bunch of operating systems, including macOS and Apple Unix, and more modern ones like NetBSD and Linux. HP PA RISC got 64-bit support. A bunch of things were removed. Some ancient ARM boards are the new thing for the final release of this year, 9.2. Some targets have been declared deprecated by their manufacturers, and we also decided to remove them from QEMU. That's Nios 2, which used to be used on some FPGAs and as a soft core, and Chris. The ESP SCSI device used to be a very important device in the 90s. It was completely rewritten from scratch, almost from scratch, by Mark A. Wayland, and the new one is a lot better at following the spec and at following the phases of the SCSI protocol. And finally, for x86 TCG, we have some fixes for 16 and 32-bit protected mode. So if you want to run Windows 95, or 3.1, or 2.0, or 1.0, 1.0 probably doesn't work for other reasons, I don't know. But anyway, if you want to run ancient protected mode, maybe, novel network, there's so many to choose from. We got some new devices, especially in the Virtual space, Virtual Sound and the Virtual GPU Rutabaga, which, if you didn't know, is a vegetable, also known as turnip or something like that in the British Islands. It's an alternative to VirGL Render. There will be some talks about it in today, and basically the interesting thing is that multiple GPU protocols can be tunneled inside virtual GPU, and the main feature that it was created for is Wayland pass-through, and it was merged this year. Also in the build system department, there was an interesting cleanup. If you don't have a host library, now you can choose to disable only some boards. Previously, you could have like this host library is needed to enable a device. For example, the U2F library can be used to enable or disable the USB U2F smart card device. Now the same thing is true for boards. For example, on x86, the only board that needs the device trees is microVM. If you don't have libftd installed, the build will proceed, but will not include the microVM board. And also, we have a final version of audio dev and audio. It took several years to have something that works, and now you can do like dash audio PA to use Pulse Audio as a default backend for your machine, and there is a model sub option so that you can pick the sound card to use and so on. It's a lot easier to use than the old one. With respect to infrastructure, QEMU.org and Patch have moved from Azure to Oregon State University Open Source Labs. We're still using Azure, however, to run our CI using Kubernetes. That's nice because it can scale out as much as you want, and it can run pretty quickly. And it's not more expensive if you make it faster, which is a nice thing to have. But we also have a new sponsorship from this September, so it's very new, which is DigitalOcean. So we will also look at moving some of the CI to DigitalOcean so that we can avoid putting all of our eggs in one basket. Security. We have more hardening done through the C compiler. For example, the call-used regs can be zeroed, and variables that do not have an initializer will always be initialized to 0. We also move the Coverity runs through the GitLab pipeline, so if it breaks while I'm on vacation, it still runs. And also, big thing that I will talk about later, let's see what was next in 2020 when I last did the QEMU status report. We were talking about moving more stuff to GitLab. Static generation moved there, the primary repository moved there, the issue tracking moved there. We decided that the wiki would stay as MediaWiki because it's a different model than GitLab, and we found a better way to host it as a Podman container, which makes the updates much easier, and therefore we kept it on the Oregon State University infrastructure. And the release processes also stayed the same, so it doesn't use GitLab. And if you wonder why it's 1, 2, 4, that was because that was the idea, was that the release process would have been easier to move than the issue tracking, but that did not happen. So we didn't really get the order or the priority of these changes. But still, we got 3 out of 5, and we have a good reason for the wiki. The release process, maybe, I don't know, something will change, maybe not. We will see. Another thing where we had a little less success was to move more towards API driven way to configure the guests. And one idea was to allow configuration of the virtual machine with QMP by extending preconfig. That didn't really happen. Preconfig mode has been cleaned up a lot, which was nice because, for example, interestingly, as a result of fixing preconfig, you can now use GTK and SDL backends on macOS, which is not entirely intended, but very nice side effect. We were also thinking of having official bindings for QAPI in other languages. So, for example, distributing Python packages or Go packages built from the QEMU sources, and that hasn't happened yet, sorry. However, we were talking about having Rust in QEMU. And at the time, the thing was like, yeah, maybe we can just focus on multi-process QEMU, vhost user servers. But actually, we got this very interesting series from Manos last June. There were lots of discussion, some of them a bit more heated, some of them a little bit more calm. But in general, the attitude, I think we can agree that was positive for everybody. We may disagree on how to get there, but no one seems to be scared of learning Rust, of learning more Rust. There is a concern of having technical debt by rushing too much into code that may not be the best Rust code. We need to also preserve expectations of the distros, the expectation that distros have of a C program, while entering a completely different ecosystem based on crates and very fine-grained dependencies compared to what you have in C. So we have iterated on this. V10 was posted in September, and it seems like it's pretty close to be something that can be merged early. As I wouldn't say as an experiment, but as a starting point to get something that is really usable. Because the important thing is to get it right. QEMU is a mature project and we want to get it right. So one topic was the build system integration, whether to invoke cargo from make or whether to go all in with Meson and invoke Rust C directly. Going with Rust C is not so easy. New Meson is required. You have to write a Meson.build by hand for all the dependent crates. But at the same time, there is work upstream into making Meson understand cargo.log files, which will make this automatic. And we decided in the end that it's a lot cleaner and easier to work with, unless you are the poor guy that has to add a new dependency. We may still have some level of cargo integration still for Clippy, for example. However, we also had to basically fit into what we do for C. We support cross compilation entirely in C code, and we need to do the same for Rust code, and that was a bit easier with the Rust C approach. Also we need to integrate with kconfig, for which there is a solution in Manos's patches, but that may not be the definitive solution. We have something, and again, we will iterate, taking care of not rushing too quickly so that we keep technical debt under control. Another small problem is the minimum supported Rust version. For now, Debian has a relatively old version. There's really just 2 or 3 issues that are interesting 2 or 3 features that are interesting from newer versions. Offset off is probably the worst. We might end up requiring something much newer than 1.63.0 for development, but we will see support building on all the supported Linux distros. This is not 2 of the patches on the list. It's one of the things that we will fix iteratively. Another small issue with cargo is Clippy is adding new warnings on every new release, and we want to have a CI job that builds will nightly Rust, but we don't want it to break every time a new warning is added. So one idea is that we disable all the linked groups, we explicitly list what we want, and when this non-fatal job that has all the groups enabled shows an issue, we can decide whether to enable it or whether it was a one-off. That's not a big problem. Final thing, I'm already out of time, so I will go very fast. The immediate goal is to have no undefined behavior, which I'm pretty sure there is something in Manos's patches, but we definitely want to remove that. We want to move towards the goal of having a shared reference for callbacks. And also, the goal is that devices should use safe code or mostly safe code. lower priority, but something that might come for free once we get bindings for error, for QEMU, for character devices, and so on, is to have also idiomatic Rust code. What does idiomatic Rust code? It means, for example, that instead of having error as a parameter that is passed by reference, you return a result, and then you also don't need anymore to return bool, for example, because you already have the difference. Is this an error? Is this a valid value in the result alternative? We can automatically generate all the external C callback and then add some conversion functions. We can have automatic reference counting. One thing that is nice, we can have type safe casting. So if I cast something from device to object, it will only compile if it is actually a subclass. If I try to do a cast from device to PCI device, I need to have error handling. But if I cast from device to object, I don't need to have error handling. So these are nice things that we can do with Rust code, and we will look at it in the future. Who can we learn from? Mesa, who's been an early adopter of Rust with Meson, specifically for the build system. glib and Linux have some different ideas, very different ideas. Probably we'll meet somewhere in the middle about how to interoperate between C and Rust code. Sorry for the typo there. And that's it. Thank you.